Hello ladies and gentlemen, this is Mr. Green. I am making another in my series of geometry videos. We should be working on Unit 1, Lessons 4 and 5 at this point. We are going to be dealing with several new issues here that you might not have thought of before. Don't forget, if you don't do well on a quiz, please go out and make corrections on it. Corrections do help you, and you can rework the problems, and it will give you some extra points by doing so. Okay? Due dates. Things close after 28 days. You do not want things to go to that point. Zeros hurt your grade worse than anything else. So let's look at some spatial relationships. Spatial meaning in space somewhere. And if we're looking at parallel lines, intersecting lines, and skew lines, here we've got a couple lines, and they're not going to move for me. No. Nope, they're not going to work for me. Okay, parallel lines. Parallel lines are lines that never touch. So we know that if we're looking at a parallelogram, across the top here would be a line that would be parallel. Down the sides, we would have lines that would be parallel, right? Well, these sides do intersect each other, and intersecting lines are one of the things that we're talking about here. Now, a skew line would be a line that is neither parallel nor intersecting. So if I were looking at a skew line, I would be looking at a line that goes like this through the center of the box, okay? It just kind of goes that way. When I was in classes, the way I would do this is I would take a pizza box. And for the pizza box, it has, a square on the top and a square on the bottom, rectangles on the side, and all those lines are either parallel or intersecting lines. And then I would take a pencil and I would stab the pencil right through the middle of the pizza box. That stabbed pencil through the middle of it was neither parallel to the sides or the edges or any other thing on the pizza box, and so it became a skew, S-K-E-W, skew line, meaning that it was not at the same angles as them. Okay? So another angle that we're looking at when we're looking at two planes that intersect each other is called a dihedral angle. A dihedral angle is the angle that the two planes are intersecting each other. So right here we've got a green plane and a blue plane, and where they intersect, this angle in here, this angle number 2, would be called the dihedral angle, the angle that they intersect each other. So when we're looking at solid objects, like going back to this one over here, there are different planes on this one. There's a plane on the bottom and a plane over here on the side, and a plane on top and a plane in front. And if you look at these if this is a cube, then the plane on top and the plane on the front intersect each other at a dihedral angle right there. That dihedral angle in this particular situation, because it is a cube, is a right angle, 90-degree angle. That's the way you would be looking at these things. You'd be trying to find the angle in which planes intersect each other. Okay? So, a convex polyhedra. Well, what does polyhedra mean? Poly meaning multi, hedra meaning sided. Multi-sided, convex. Well, we know what convex means. Convex means it doesn't cave in, right? That means all the sides are flat and don't cave in. We don't get Miss Pac-Man, right? That would be a concave object. A convex object doesn't cave in like that. But we're looking at a three-dimensional object, so we're looking at Miss Pac-Man 3D, which is more like a sphere, okay, that is open, something like that, okay? That would be a convex type polyhedra if we were looking at circles. But we're talking about sided objects, so circles don't really work, and neither do spheres. But this one would, and this one would. These are all convex polyhedra. Okay? Now, one of the things we can do with these polyhedra is lay them down on one side and then cut them open and lay it all open. I'm sure you all have taken a box and cut the box and laid the sides out on it before. What they've done here is taken an octagon, an octahedron, and they've laid it out. How do we know that they've laid it out? Well, 1, 2, 3, 4, 5, 6, 7, 8. 8 sides, octahedron, multi-sided polyhedron. So it is an 8-sided polyhedron. Laid them all out. They're all triangles. And when these triangles are folded back up, you would get this octahedron over here. This is called a net. It's not like a net that you would use to catch butterflies or a net that you use to catch fish. It is a net in the sense that we've laid out the sides so that we can see what they are in a flat object. So it's a way of representing a 3D object here in a 2D environment so that we can see the sides. This is very useful when we're calculating the area that these 2D sides would take up, or surface area of the polyhedra. Okay? So those are the concepts that we're looking at in these 2 units. You're going to be trying to lay out some nets and trying to get some things to lay out in your test questions. I will be working some problems in the Class Connect, so you're welcome to come to Class Connect and get some help with some of these problems. Some of them are going to be confusing. 3-sided or multi-sided objects like this can be a confusing situation. Feel free, come by, let's talk. Make certain we understand them. Okay? I do appreciate when you're sending me K-mails and emails that you are including the course that you are in, the fact that you're in geometry, and what section number of geometry you're in, because it does help us make certain that I'm getting the right information to you every time. Okay? So, I look forward to talking to you next class period.